All right, good morning, Math 10C. I'm about to go through and record the video for the Equations of Linear Relations lesson number 3, the general form of the equation ax plus by plus c equals 0. This can be found on page 571. So take a second to flip there and get yourself organized. It looks kind of short, the lesson in general. It's only 2 pages, and the reason for that is we're spending a lot of our time starting to write linear equations with what we call the slope-intercept form, which is what they're referring to at the very top here. It says in lesson number 2 we used y equals mx plus b. So I'm going to write a little note that the slope-intercept form, just as it sounds, has a variable that corresponds to slope and a variable that corresponds to the y-intercept. That's your form y equals mx plus b, where m is your slope and b is your y-intercept. Okay, we're going to look at a different form of that line. It's called the general form. It looks like ax plus by plus c equals 0. And so we say in this form, a, b, and c are integers, but if possible, try to write a as a positive value. So we're going to practice that. If a comes up negative, we're going to take everything, multiply it by a -1 so that it turns positive. And so this general equation of the line allows us to write equations for oblique lines, horizontal lines, and vertical lines. Whereas we just learned in lesson number 2, writing the equation for vertical lines gets pretty tricky when you're trying to write it in the form y equals mx plus b. Because you can't have a y equals, it has to be x equals. So this sort of gets around it, because you're allowed to have an ax value equal to 0, but you don't have to have a by or a c. Those can both be 0. You could have an ax and a by, but no c. Like, you can mix and match here. And so we're going to work through how do we get from this slope-intercept form or use the characteristics of our line to try and get this general form of the ax plus by plus c form. And really, it's only one more step from what we're used to. So I'm going to start on class example number 1. Convert the following from slope-intercept form, y equals mx plus b, to general form, ax plus by plus c equals 0, where a, b, and c are integers. And so here I see y equals mx plus b, y equals 5x minus 8. And I'm noticing in that general form, one of the key characteristics about it is that x, y, and your constant are all on the same side. Okay, so you have an x value, you have a y value, and you have a constant all on the same side, and the other side is equal to 0. So one of my first steps here is going to be trying to set one of these sides equal to 0. And so I'm going to choose to set the side where y is equal to 0, which means I have to subtract y on both sides. So y subtract y goes to 0. And when I write it, I write 5x by, so in this case I had minus y, plus c, in this case the constant, which is minus 8. So 5x minus y minus 8. All I did was take the y from this side, subtract it onto this side, and put it in between the x and the 8 because I have to match this x, then y, then c format. So actually, there is my answer. That's my general form. Here's a, here's b, and b is -1, and c is -8. I'm done. Okay, let's look at b. Y equals 2/3 x plus 7. I'm going to copy what I did in the last example. I'm going to take that y value because I'm trying to set that equal to 0. This is supposed to be ax by c equals 0. So I'm going to take that y value, subtract it to the other side, and put it between the x and the c value, or the constant. Okay. So I've done that. I could argue almost right here that this is general form, except there's a special condition on general form that says a, b, and c have to be integers. And a right now is not an integer. That is a fraction. And so I need to choose to manipulate this equation by multiplying by a number that would get rid of the fraction. So in this case, I see a fraction over 3. If I multiply everything on left and right side by 3, I should be able to write an equation equivalent to this, but with integers only. So I'm going to go ahead and I'm going to multiply everything by 3. I'm going to show that by drawing square brackets and then multiplying by 3. 3 times 0 is still 0. 2/3 times 3. 2/3 times 3 is 2. The whole point of doing that was to get rid of the 3, so just a 2 left in the numerator. This used to be a -1y. -1 times 3 is -3. +7 times 3 makes +21. My format, ax, by, c. 2x minus 3y plus 21 equals 0. That's my general form. Okay, if I'm looking at this one here, starting out the exact same way I have been with my others is I want to try to get one of these sides equal to 0. And so it's easier to move the y rather than to move the 1/4 x and the 3/5. You can if you want. It won't make your solution any less correct. But I find it easier to move the y, and we'll deal with the rest of this later. And so I see -1/4 x. I'm subtracting y, putting it between the x and the c value, plus 3/5 for the c value. So -1/4 x minus y plus 3/5. And so first thing I want to do, or once I have this all here, I need to multiply by a number that would get these to be integers, a, b, and c to be integers, rather than fractions. And so I have a 1/4 and a 3/5. And I need to choose a number that would get rid of both the 5 and the 4 in the denominator. And the easiest way to do that is to choose 5 times 4 or multiply everything by 20. So I go ahead, I multiply by 20. I now have, whoops, that's 0, because I got rid of that y. 20 times 0, 0. -1/4 times 20, and so no shame, go on your calculator. What is -1/4 times 20? Should give you -5x. -1 times 20 is -20. 3/5 times 20, I would go on my calculator. 3/5 times 20, 3 times 20, 60/5, or 12. And so this is fine. This is ax, b, and y, where a, b, and c are integers, because -5 is an integer, so is -20 and +12. However, we said, okay, well, to be neat, to be tidy, maybe that should be a positive a value. So I'm just going to go ahead right now. Again, I'm going to almost do another multiplication step. Multiply by a -1, which changes all my signs. So the -5 multiplied by -1 is now +5. -20 is now +20, and +12 is now -12. So both of these are correct. Both would get you some marks, but the one with the positive a value is nicer. Okay? All right, so let's look through now on class example number 2. Can we go backwards? Can we give you general form, ask you to find slope intercept form? And so the answer is yes. Just reverse what you had just done. We had been moving y over, and we're going to do the same thing. We're going to move y back over so that it's not 0, but it's a y equals. So I'm going to do the same thing here. Okay, I want this to be y equals mx plus b. So my x, the 2x term, and the 25 stay together on the same side, but the 5, or the -5y, has to come across by adding it or changing sides. So that's a +5y. To get this as y equals, not 5y equals, 1y equals, I need to divide everything by 5. And so I go 2 divided by 5, x, 2/5 x, 25 divided by 5 plus 5. 2/5 x plus 5. And so what would be the slope? 2/5. The y-intercept, 5. Okay, maybe we'll write that there because they asked us what was the slope, what was the y-intercept. So I've answered the question. Okay. Again, determine the slope and y-intercept of this line. 6x plus 2y minus 15 equals 0. We want y equals mx plus b. That means y has to be opposite the side of the x and the constant. So now I have 6x minus 15 equal to negative 2y because I took my positive 2 and I wanted to subtract it to the other side. And I don't want negative 2y, I want 1y equals. So I'm going to do the same thing as I had in the last step. Last time I divided by by positive 5. Divide everything by negative 2, so I get y equals 6 divided by negative 2, negative 3x. Negative 15 divided by negative 2. Negative divided by negative is positive, but I can't simplify the fraction. 15/2, so I'm just going to leave it. Slope, the number in front of the x, mx, negative 3. The y-intercept, the b value, or the constant, 15/2. Okay. I don't think I want to do the next example. I'm going to skip the next example. Okay, so let's move on. Class example number 4. Which of the following lines is or are, so it could be more than one, perpendicular to the line 4x minus 2y plus 9? In order to answer this question, I have to know, first of all, what is the slope of this line? Because I need to know what's perpendicular to that line. So I'm going to start by sort of taking this equation they gave me, 4x minus 2y plus 9, over to the side. And I want to know what is the slope of that line. And the way to find the slope of that line is to work in slope-intercept form. So to get this from general form, as it is right now, to slope-intercept form, which is mx plus b, x and the b value, or before I manipulate it, but the x and the c value right now need to be on the same side, and the y needs to be on the other side. So I'm going to add 2y in order to take it to the other side, so that I get 4x plus 9 by itself equal to 2y. And because I need to get in slope-intercept form where there's no numbers in front of the y, or a 1 in front of the y equals 4 divided by 2, 2x plus 9/2. And so here's my mx plus b form, which tells me my slope of this line is 2, which means the slope of the line I'm looking for, which is perpendicular, and remember, I'm going to make myself a little note here, that perpendicular means the negative reciprocal. The negative reciprocal of 2 is negative, and then flip 1/2. So it's possible that one of these lines has a slope of negative 1/2, or more than one of them. And so in each case, I'm going to figure out in slope-intercept form, what does the equation look like? And then I'll be able to state what the slope is. So following the same steps from general form, ax plus by plus c, to slope-intercept form. X and the number stay together, x and c, ax and c I should say, stay together. We want to take y to the other side. We do that by, in this case, taking away 3y. So that 0 minus 3y equals negative 3y. Divide it all by negative 3. 6 divided by negative 3 is negative 2x. Negative divided by negative is positive. 1 divided by 3 is 1/3, equal to y. And so I'm looking at the example in A, and so I'm going to say slope is negative 2, mx, slope negative 2. And so in order to be perpendicular, the slope was supposed to be negative 1/2. This one has a slope of negative 2. So in fact, this one's not perpendicular. And then maybe write a note, not perpendicular to that line. Let's go to number 2. I'm going to use the exact same process. X and the number stay together. The y gets subtracted to the other side. So positive 2y, I subtract 2y, so that 0 minus 2y is negative 2y. mx plus b form says no numbers allowed in front of the y. So I divide by the negative 2, and then I just simplify. In this case, I have to pretend there's a 1 in front of the x, so that this becomes 1 over negative 2x, or negative 1/2 x. Negative 12 divided by negative 2 is positive 6. Slope is the m value, mx plus b. mx plus b, m is negative 1/2, because it doesn't matter if the negative's top or bottom, the value is still negative 1/2 or negative 0.5 if you put it in your calculator. So this slope is negative 1/2. The slope of the line that was supposed to be perpendicular was negative 1/2. So in fact, this one is perpendicular. At least number 2 is perpendicular. I have to check number 3. A little bit easier because there's no number there. So I just have 5x plus 10y equal to 0. I move my y value across by taking away the 10y, so that 5x equals negative 10y. I want to get y alone, a y equals negative, or divide by negative 10, both sides. 5 divided by negative 10, well I know 5 divided by 10 is 1/2, and it's negative, so this is negative 1/2 x equals y. I'm looking for that mx plus b form. There's no plus b, or I can imagine a plus 0, so in fact the y-intercept is 0, but what's important here is that the slope, in this case, slope is negative 1/2. That's what it was supposed to be in order to be perpendicular. So it turns out line 3 is also perpendicular to that given line. So if I was to answer the question, which of the following lines is perpendicular? Line 2 and line 3 are perpendicular. So line 2 and line 3 satisfy that equation. All right, class example number 5. Write the equation of a line which is perpendicular to this line, has the same y-intercept as this line. This is almost those 2 criteria questions again. Pick one characteristic out of the first line or another characteristic out of the second line. So I'm just going to kind of split this up for myself and say, okay, here's my first line. Here's my second line. And from this line, the 2x plus 5y minus 7, I need to know the equation of the line that's perpendicular. So I'm after the slope. I want to know what slope is perpendicular to that line. And if I go over here, it said and has the same y-intercept as this line. So in any manipulation or algebra I'm going to do, I need to find the same y-intercept as that line, or I need to at least know what the y-intercept is. Okay. All right. 2x plus 5y minus 7 equals 0. I'm trying to go to slope-intercept form. It seems we do that more often than going the other way, putting it in general form. The reason for that is that slope-intercept form is so useful for us in drawing. As well, it's a y equals line, which I could graph. So starting again the same way I have been by taking the y value to the other side, so that 2x minus 7 equals negative 5y. I'm going to have to kind of go around my work here because I wrote a little bit too high. So I have 2x minus 7 equals negative 5y. Divide by negative 5. So then I get 2 divided by negative 5, or negative 2/5 x. 7 divided by 5, negative divided by negative is positive, plus 7 over 5 equals y. And so if I was going to take this form is, okay, the whole point of manipulating this is so mx plus b. Slope, negative 2/5. I don't need to draw this line to know that the slope is negative 2/5 because it's in my slope-intercept form. So to find the slope that's perpendicular to that, perpendicular, negative flip. Negative reciprocal of negative 2/5. Negatives become positive, and we flip. So not 2/5, but 5/2. So the slope that I needed to write the equation of the line was 5/2. Now I go back here, and I have a new equation, but from this equation, I'm not after the slope. I want to know what's the y-intercept. And so I'm going to move the y value across so that I get this in slope y-intercept form where the ax and the c stay together. 2x minus 6, I've subtracted y to the other side, so equal to negative y. I need that equal to 1y in order for this to work, so I'm going to divide by negative 1 to get rid of that negative y. And I get negative 2 divided by negative 1, x. Negative 6 divided by negative 1 is positive 6 equals to y. And so my y-intercept here, mx plus b, b is my y-intercept, that's 6. So the y-intercept is 6, a slope that's perpendicular, so 5/2. So here's where the work gets harder. We're going to go over here, just going to draw a line and go underneath it. Here was my equation of my line. The equation of the required line. In slope-intercept form, y equals 5/2 is the slope, x plus 6 is the y-intercept. And so it's an answer in slope-intercept form, which I had. Here's my answer. Check, 1 mark, slope-intercept form. But I also need to know what is the general form. Going back to the ax, by, c value all on the same side, which is okay by me because I can go here and decide where y is to 0. Really easy for me to move that y over and put it in between the ax and the c value. So I'm going to go 5/2 x minus y plus 6. Okay, ax, by, c. Got to get rid of the fraction though. This is fine if a, b, and c were allowed to be fractions. If they said they're allowed to be rational numbers, that would be fine. But they need to be integers, so I need to get rid of that denominator of 2. I do that by multiplying by 2. 0 equal to, makes the 2 disappear by 5/2 times 2 is just 5. X, negative 1 times 2, negative 2. Y, 6 times 2 is 12. And so in slope-intercept form, y equals 5/2 x plus 6. In general form, 5x minus 2y plus 12 is the second requirement there to get the general form. Okay, the very last question of this video. A student made the following statements about the line with the equation 2y equals 5x plus 12. They said statement 1, the line has a slope of 5. Statement 2, the line is parallel to 10x minus 4y plus 13 equals 0. And statement 3, the line passes through negative 2, 1. Which of the above statements is and are true? And so when I look through this, I see that they're pairing them, 1 and 2, 1 and 3, 2 and 3. It's likely that 2 of the answers are true and 1 is false. We have to figure out which statements are true and which are false. I like to take this out of the sort of the information box and try to decide which one is true or false, or work with this for each statement. So the line has a slope of 5, and now I'm tempted here. mx plus b. Oh yeah, slope must be 5, but I would be wrong. because there's still a 2 in front. So if I divide everything by 2, I would say y equals 5 divided by 2x plus 12 divided by 2 plus 6. 5 halves x plus 6. Well, the slope then is definitely not 5, which means statement 1 is false. And if statement 1 is false, A and B are gone. Which if I had to guess now, I would choose C. But to be thorough, I'm going to go through and make sure that C and D are correct. Or that C, that it is one of C or D, which one, that statements 2 and 3 are correct. Okay, statement 2, the line is parallel to this line. Let's take this line for a second. And this general form is useless most of the time. It can't tell me the slope, can't tell me the y-intercept, no characteristics of the graph. So I'm going to work on getting that into slope y-intercept form by getting or letting x and c, ax and c be on the same side, taking that 4y to the other side by adding it. And then to get it in the mx plus b form where it's y equals dividing everything by 4, 10 divided by 4 simplifies to 5 over 2x plus 13 over 4. And so if I was to look and try to say, okay, I know this line now in slope-intercept form is the line I was given parallel to this line. And my answer would be yes, because both of the slopes are 5 halves. So this is parallel, or my looks like the 2 straight lines parallel to the given line, which means statement 2 is true. Okay, so I need to check then, is statement 3 true? Because if statement 3 is not true, I'm going to choose D. But if statement D is true, I'm going to choose C. Does the line pass through -2, 1? And so we haven't really been checking if these values, we know how to get a table of values, how to plot some points, but we haven't really been checking if these work. And so if we're going to check that this line passes through that point, that tells me that if I plug in x and y, I'm going to copy down here the original equation I had. This is an equation. In an equation, left side is supposed to equal right side. If I plug in this xy, this -2, 1, where x is -2, y is 1, and this works, that the equation is true, left side does equal right side, it is on the line. If it's not true, that this point does not satisfy this equation, that point's not on the line. And so I'm going to go through and say 2 times y, 2 times 1, equal to 5 times -2 plus 12. 2 times 1 is 2. 5 times -2 is -10 plus 12. And because -10 plus 12 is 2, left side equals right side, and I could say the point is on the line, which means statement 3 is true. And so I can go ahead and circle C, being confident both 2 and 3 are true, and it's not just 2 only, and answer the question. Okay, that was a really long lesson. I'm going to go through with you really quick here on the side. I don't have the pages printed for the homework, but I've got my book in front of me, and so we can choose a couple questions for the assignment. I don't want you to spend an enormous amount of time on going back, or how do I say this? Going from one form to the other. What's important is that recognizing that this is another way of representing a linear equation, typically the one that's used in calculus, actually. And it's got its usefulness in the fact that we can write the equations of horizontal, vertical lines by changing the values of A, B, and C. but we're limited in the fact that we always have to convert to slope-intercept form to decide all of the, or answer all of those questions about parallel, about perpendicular, about y-intercepts. So let's go ahead and let's do number 1. Don't have to do C though. Let's do number 1. Let's choose A, B. Let's just do A, B, E. A, B, E is good. That gives you a little bit of a mix. Let's throw D in there actually. A, B, D, and E. That gives you a mix of no fractions, 1 fraction, and 2 fractions. Let's do half of number 2. Half of number 2. Um, 4 and 5. That'll be the only parallel perpendicular ones I will give you, as well as the matching. Number 8 is a good matching question. And then I'm going to write the note at the bottom here again that you should try all of the multiple choice. There we go, multiple choice. Because I typically like to look at these questions and rewrite them by changing the numbers and put them on the test. And if you study the multiple choice, you'll be really well off. So 1 A, B, D, E, that's 4 questions. Half of 2, you choose your 3, 4, 5, 8, and the multiple choice. All right, thanks for watching and get to work.